Grade 11s, we're looking at compound interest today. Just as a recap, let's look at simple interest from yesterday. So simple interest is where you earn interest only on the principal that you invest. So our formula is interest equals principal times rate times time. So for the first one, we have $350 at a rate of 8% for 8 months. Remember, your time needs to be in years. Your rate should be in a decimal, and we just multiply. Principal times rate times time. 350 times decimal 08 times 8/12, because it should be in years, gives me interest of $18.67, which means the total amount that I have is $350 principal plus the interest, which would be a total of $368.67. So for the amount, you have principal plus your interest. If we had $130 and we wanted to know what the principal was in order to earn that interest, our only formula for simple interest is that one. So if I have $130 and I want to know the principal, 10%, 6 months in years would be 6/12. To get that principal, I do a lot of division. 130 divided by 0.10 times a half, or 6/12. I end up with a principal of $2,600. So my total amount is $2,600 plus that interest, $2,730. Same for the next one. If I want to find the rate, I'm going to be doing some division. So my interest is $40 that I earned on $700. I want to know what the rate is. 9 months in years is 9/12. So to get my rate, I would have 40 divided by the 700 and the 9/12. Notice I always use brackets. No matter what your calculator is like, that can be helpful. 40 divided by 700 times 9/12. I have decimal 0762. So my rate as a percent would be 7.62%. The amount, well, I could have already figured that out. It's the principal plus the interest, $740. The next one, I want to find the time in days and then the total amount. So I have interest. I have the principal, it's $6,000. My rate is 12%, and I want the time. Now when I do my calculations, I will get time in years. 450 divided by 6,000 times decimal 12. Decimal 625, if I want that in days. Decimal 625 times 365. And I will have my time as 228 days. My total amount is the 6,000 plus the 450. We use the principle of simple interest to calculate compound interest. Compound interest is just a little bit different. The interest rate is applied to the original principal and any accumulated interest. So the difference is that with compound interest, you earn or pay interest on interest. Our equation is the original amount this is the total amount times the rate We know this from exponential functions that for a rate of growth, which is what money does, it has to be greater than 1. So we have 1 plus the percent of growth. That's your total rate. N is the number of compounding periods. Let's look at an example. Okay, which is a better investment for 5 years? $1,000 at 8% simple interest or $1,000 at 7.75% compounded interest. So for our simple interest is always calculated on the principal, which is $1,000. The interest, so we have 8% simple interest, 1,000 times 0.08 is $80. So the accumulated interest so far is $80. Year 2, you've left it in the bank for another year, you get another 8% of your $1,000, you get another $80. So now you have a total of $160. The next year you get another $80. The next year you get another $80. The math is pretty simple with simple interest. Ha ha. Another $80. $400 accumulated interest. So at the end of the 5 years, your total amount is your $1,000 plus $400 in your account, $1,400. The math is a little harder with the compound interest, but it can certainly be helpful if you're saving money, not so much if you're borrowing it. For the first year, you put in $1,000. Your interest, which is 7.75%, so $1,000 times 0.0775 gives us $77.50 interest the first year. So our accumulated interest is $77.50. So far, it's the same. However, your account balance is now $1,077.50, and that's what you're going to earn interest on. $1,077.50 times the interest rate, we will get $83.51. So your accumulated interest, when I put that with the $77.50, I get $161.01. So in my account, I have $1,161.01, and that's what I'll earn interest on. Whereas with simple interest, I'm only ever earning interest on that $1,000. Now I'm earning interest on the interest. So for this calculation, $1,161.01 times our rate is $89.98. I'm going to add $89.98 to $161.01, and $250.99 is my accumulated interest. Put into the that $89.98 is put into the account, $1,250.99, and that's what I'll earn interest on. $96.95, that's added to the account. My accumulated interest is $347.94. That's added to the account. The $96.95, I end up with $1,347.94. I earn interest on that. $104.47. total accumulated interest, $452.41. Final amount is $1,452.41. But we certainly don't want to go through a table every time. That's what that equation is for that we looked at just a moment ago. So let's look at Jackie. She invests $900 in a GIC that pays 5% compounded annually. So that's the magic word that tells us it's not simple interest, it's compound interest. It's a one-shot deal. She invests $900. That's it. She doesn't do anything monthly. That's a totally different scenario. So a one-time deal with the word compound in the question. We have a compound interest question, and this is the formula that we have if we don't want to do a big table again. We want to know the amount when the investment matures. So that means her $900 plus the interest, and that's what this equation will give us. For her amount, she invests $900. That's our principal or initial amount. Our rate is 1 plus the 5%. And the number of compound periods is how many times interest is added to that account, and it is done annually for 4 years. That means our N value is 4. So we're going to put that equation into our calculator. Total amount is $1,093.96. If I asked you how much of that is interest, we would simply take the amount, subtract what she invested, and we would have our interest, $193.96. A principal of $200 is invested at 7%/A. That again is per annum. By Canadian law, we have to give our interest rates per year. And this is compounded, so there's the word that we're looking for. Annually for 5 years. Graph the amount of the investment at the end of each year. So at the end of the first year, let's write our equation again. At the end of the first year, it was $200 principal at 1 plus 7% would be 1.07 to the 1. If we type that into our calculator, we will get $214. Let's say you decide to leave it in for another year. 200, 1.07 to the 2, $228.98. So we're looking at the amount, if you leave it in over the course of these 5 years, we should see exponential growth. Okay, let's type these into our calculator. $245.01, $262.16, $280.51. Let's graph this. So our independent is the number of years. The amount of the investment depends on how long you leave it in the account. That will be in dollars. Okay. 0. Let's see, I want 5 years. I think every third will fit nicely. Came to record these videos tonight, and there's a bird in the math office. I don't know how he got in there. I'm trying to shoo him out. But if you hear little squeaks, it's not my dog this time. 200, 300, there. All right, initial value is where our little story begins, or the y-intercept, which is $200. After a year, we have $214, so my grid goes up by $25. just higher than half square. There we are. Year 2, 228.98. So just passed. Year 3, 245.01. Year 4, 262.16. And year 5, 280. It's hard to see exponential growth in such a short time frame. Let's just have a look way down the road. What would the amount be if we left that $200 for, let's say, 50 years? So we put in our $200 at 7%, which is not a bad rate, for 50 years. $5,891.41. Cost you $200, and all you had to do was just leave it alone for a long time, and it made an awful lot of interest. You've noticed in the two questions that we've done that the interest has been compounded annually, but it's not always calculated annually. If it's calculated more often than annually, then two things get affected. The I changes and the N changes. If your banker compounds your interest, say you had 8%, and he didn't just add interest to your account annually, but semi-annually, then your banker would go broke if he gave you 8% both times each year. You know, time works against us with money, so he would give you 4% semi-annually. So he just divvies it in half, gives you 4% each time, and it works out. So your I is the interest rate that we have as a percent annually. And you divide it by the number of compounding periods. For example, if you were given 8% per annum compounded monthly, we would calculate our I as 0.08 divided by 12, which would be the monthly rate they would give you each time they calculate your interest. 0.08 divided by 12 is less than 1%. 0.006 repeating forever and ever as your monthly rate. The N value also gets changed. If you get 8% per annum and it's compounded monthly for 3 years, your banker is going to sit with your 0.006. He's going to give it to you every month for 3 years. He is going to do that calculation 36 times. He's going to do it every month for 3 years. So we're going to take our years times the number of compounding periods in a year. So maybe you want to write this one off to the side as well. If you have, and the 8% doesn't matter, but if you have 8% per annum compounded monthly for 3 years, our N would be 3 years times monthly, 36. Okay, let's do a couple of questions. Nick borrowed $45 to buy a hamster at 8% per annum compounded monthly. So by Canadian law, it's written down as a yearly rate. We have to figure it out as a monthly rate. We also want to know how long. It's for a year, but it's compounded monthly. So both of those things are going to change. Our I value is 0.08 divided by, and the word that I'm going to look for is monthly. So our I is 0.006 repeating. Our N is monthly for a year. That will be 12 times 1, which is 12. Now we can do the math on his loan. How much is the amount owing? So he owes, principal is $45. Our rate is 1 plus 0.006 repeating. The more accurately you can put it into your calculator, the better. The number of times they calculate their interest is 12 every month for a year. And his total is $48.73. Not so bad. Cody lent Michael $300 a year for a graphing calculator, if you must know, at 10% per annum, compounded weekly. So compounded weekly is important. 10% per annum, $300, and we want to know how much interest. So that's a little bit different. The only formula that we have is for the total amount. So we'll have to do another computation in a minute to figure out the interest. Let's calculate our I value and the N value, knowing that it's not compounded annually. If it's compounded weekly, we're going to change the rate of 0.10 by the number of weeks in a year. I hope you know that. It's 52. So our interest rate weekly is 0.001923. Our N value is every week for 1 year. So the number of years is 1, number of weeks is 52. They're going to calculate the interest 52 times at 0.001293 is the rate. So here's the amount. $300. 1.001923 to the power of 52. That will be the amount that Michael owes. Remembering to round to 2 decimal places because it's money, 331.52. We were actually asked for the interest. The interest is the amount subtract the principal, which is 331.52. I know you can do this in your head. It's $300, which is $31.52 he owes him in interest. It is a really good idea to try that handout that I've included in your booklet to practice changing I and N. It would be so disappointing to make an error there. And then some compound interest questions out of your textbook.